Here let's look at the half adder and the full adder. So now our circuit is a multiple output circuit. The output will consist of two bits, the sum bit and the carry bit. We'll call the sum bit S and the carry bit C. The half adder is going to add two bits. And now at this point we are only doing binary addition. So this is truly binary addition at this point, base 2, without considering a carry from previous additions. That's what a half adder will do. So that's our sum. The full adder computes the sum bit and the carry bit when two bits and a carry are added. This again is binary addition. The inputs are going to be the bits X and Y, and the carry bit again will be C. So the outputs, you will have an output for the sum and for that new carry bit. So let's first recall binary addition, base 2. So this is not Boolean addition here. This is base 2 binary addition. If you have, so maybe I could put little sub 2's down here to remind you that this is, my question is, what's the binary addition? These are 2's. Okay, so I look and I say 0 plus 0, well that will just be 0. 0 plus 1 is going to give you back 1. If I do 1 plus 0, I'm going to get back 1. But what about 1 plus 1? Well, 1 plus 1 is going to give you back 0, carry 1. So we had the sum of 0, but then we had to carry 1 to the next place, which is 2 to the first, because we know we should be getting back the value of 2 there, 2 to the first. So again, this is just 0, 2 to the 0 power. This is 1, 2 to the 0 power. This is 1, 2 to the 0 power. But now I have 0, 2 to the 0 power, but I also add to that 2 to the first power. So that's my binary addition. Now let us add these values given in base 2. So I did put the subscript 2 there to remind you we're doing binary addition at this point, base 2. So if I do 1 plus 0, I know I get 1, and then we carry, so this is the sum, we have sum 1, and we carry a 0, there's nothing to carry. So we just do 0 plus 0, and then plus another 0 is 0. Again, we don't carry anything, it's just carry 0. But you know, you're thinking about if you did have a carry, you would carry it over here. 0 plus 1 is just 1, and then 1 plus 1 is going to give you back 0, carry 1. Okay, so then at this point we know that we do 1 plus 1 is going to give us back 0, but I need to carry 1, and then if you add 1 more to that, then you get back sum of 1, but I carry 1. So this is what you end up with. So you can notice that this is going to be the problem. The problem here is when we're going to start adding 3 together, we'll have to use what's known as the full adder, because as we said earlier, the half adder is going to add 2 bits only at a time. So as we're adding 2 bits only at a time, we can do that with the half adder, not the full adder. And the half adder, again, adds 2 bits, and this is binary addition, without considering a carry from a previous addition. But this is the truth table for the half adder. So it is going to output, still, as we saw earlier, it's going to output a sum. So for example, it's going to output a sum when you take 2 binary digits and add them together. Here's our sum, and it will output a carry. So it does do that. So it's going to, for 1, 1, it's going to output this sum 0, and the output will be the carry 1. But it's not going to be able to add these 3 together. It doesn't add those values. Okay, so for this example, if you input 0, 0, then the sum is going to be 0. There's going to be 0 carry. If you input 0, 1 into the half adder, what do you get back? 0 plus 1 is sum 1, carry 0. 1 plus 0 is sum 1, carry 0. Now 1 plus 1 we know is sum 0, and you need to carry 1. So those are the output values. This is the truth table for the half adder. Now we can get the sum of minterms form for this. If we look at the ones, you have to do 1 for the sum and 1 for the carry. So if I look at the sum to start with, because there's 2 outputs, I'm going to look at the 1 here. So I need to make this into a 1 and 1. So it's going to be x complement y. And then I also have another 1 here I need to add. So to make these both 1s, I keep the x and do y complement. So that's what I have for the sum part in its sum of minterms form. We could also write it this way. So this is equivalent to x plus y and x, y complement. And you have to do 1 for the carry as well. And if you notice in the carry will just end up being x, y, because you just have 1, 1 right here, and they're both 1s. So the sum of products form, the sum of minterms would just be x, y. And that's for the carry output. So now that we have our Boolean expressions for these output values, we can build our logic circuits to represent these. Okay, so I've written down the sum and the carry representations. And when I draw the circuit, so what I'm going to do is I'm going to take x with y and send them both. So I'm looking at this part right here. Send them both to be added. So this is ORed. Okay, so that is going to give me x plus y. And then we know that we need to have it ANDed or multiplied by x, y complement. So first I need to get the product of x, y. So let's just, again, use this x. We're going to use this y. Send it to be multiplied. So those are going to be AND. But that now I need it to be complemented. Okay, so that's that part, but now we need to take them both together and get those multiplied, and. So there's your AND gate. So this output is going to be the sum as listed up here. Okay, remember the carry? The carry is x and y, and we already have that, x times y here. So we're going to take that, and let me put the node here to that we're tapping into the x times y, and we're going to send it out as our carry out. Okay, and that is the half adder. And now this is the full adder. This computes the sum bits and the carry bit when 2 bits and a carry are added. So this is binary addition again. It's used to add the 3 bits. The inputs are x, y, and the carry bit c. So you have something that you're carrying in to that. The inputs are the sum bits, which will be the outputs, I'm sorry, are the sum bits we'll call s, and the new carry bit we'll call c sub I plus 1. So notice if you input 1, 1, 1, this is now when we do our sum. We know the sum is going to be 1, and then we carry 1. Here we're going to look at what is the sum. So the sum is going to be 0 on this problem, but we had to carry 1. So we're just listing those, but we have 3 now in the inputs. So this is the truth table. So if I form the circuit here, the circuits for this, I want you to first to note that you can get the output sum and output carry Boolean expressions in the sum of products form for the full adder by taking those minterms from the truth table. So you can do that, and you can look at your textbook to see those output values. But this is what's happening. So what's happening is you have X1, these are the bits to be added. They're going, and Y1, they're going into your half adder so that this half adder is going to produce a sum and a carry out. Just like when we're adding those two bits, you produce a sum and a carry out. So then you take these values, and remember at this point now you're going to have a carry in. So this carry in for the full adder, you're going to have something where you're carrying into it, so you can add 3 terms. So where's this coming from? Where's this carry in coming from? If I could squeeze something in here, I'll just draw an arrow to show you that you really have 2 values, like I'll say X naught and Y naught that you started with. You're sending those into a half adder because they're just 2 values that are being added. We'll call it the half adder there. So it produces a carry out. It produces a carry out, which is really the carry in for your full adder. Okay, so you're just taking those 2 values, and then it produces a carry out, but it's the carry in for your full adder. So it's the one that you're adding with the other 2 values, like when we were doing 1 plus 1 plus 1. Okay, so this is again sent over to the half adder so that you have a sum and a carry. And the output for any half adder is a carry and a sum. So as you can see, we're going to send this to be ORed here. And then that will end up to be your resulting carry. You just take the carry coming out of this half adder and this half adder and combine them, and that's your resulting carry. And then we have our sum already on that bottom part.